For this lesson in Unit 4, we're looking at constructing angles and parallel lines. So we're going to try to take an established angle and use the properties of it to copy it onto a new angle. So if we are given angle A, as shown below, and we're trying to create angle R to match it, that's essentially the task here. First thing we want to do is give ourselves a baseline for one of the rays of our new angle. So any angle is made up of two rays. We just draw the first one arbitrarily. And that's what you see with my point R here. I extended a ray, and it can go in any direction. Doesn't make any difference. You can go in the same orientation as the original angle, or you can rotate it, whatever you want to do, as long as you have a base ray that you can work off of. So that's the first step. Once that's done, you have something to work with. You're going to go back to your original angle and make what's called a reference arc. So you need to set your middle point of your compass on the vertex of the original angle, which would be angle A, and you can make your compass width whatever you want as long as it crosses both of the rays of the angle. So this compass width was set to whatever this AC length is, and also the AB length. Those are the same length because it's a radius centered at A. So I make my arc, and as long as it crosses through both, I'm good. I just want to label those 2 points. So I labeled them B and C. And now I have my reference arc. Alright, so now once I have that reference arc, I don't want to change the compass size. I need to come over to my new angle and reproduce that reference arc. So I set my middle point on R, and without changing the distance, I make my arc through the original ray of the second angle. Now this RT wasn't here to start with, it's just RS. And so that arc here is the same distance from R as this arc was from A. Right? That's why it's called a reference arc, because I'm trying to establish something that's going to be the same distance on both angles. So I've labeled that arc with an S, and I don't know where to draw it through at that point. Right? It's just an arc and a ray. So to establish the second ray, what I need to do is take my compass back to the original angle and set the middle point on B and the pencil point on C. Now what I'm actually doing here is measuring how wide that reference arc is. So if I have my 2 compass points on B and C, I'm figuring out how wide that is. The reason I need to do that is you can imagine if I drew my reference arc down closer to A, then the arc would be smaller. And if I drew it further from A, the arc would be bigger. So the size of that arc, the distance between those 2 points, will vary depending on where you make it. And so that's why we need to measure it now. So once I have that measurement, that BC measurement, now I can come back and measure from S to T and mark that off. And that will guarantee that I'm going the correct distance along this arc to reproduce the angle. And that secondary ray goes in there. Alright, so that's how this is done. We want to start with a reference arc, and then we want to measure how wide the reference arc is, and measure that same distance along our new arc. Alright, so then to give an informal proof or a paragraph proof, and this is important, this kind of explains why all this works. So by constructing that arc BC, we establish that reference arc, and that's important because as we go further or closer from A, that distance between the rays changes. So again, it's wider out here than it is in closer to the vertex. So then when we measure the distance from B to C, we determine how far apart the rays are at that exact point, and so intersection point T represents that same distance between the new rays at the same distance from the vertex. So we're just trying to keep everything in control, everything the same. We want the distance from the center to be the same, and we want the distance between the rays to be the same. Alright, so to do some more practice with that, we're going to create a copy of this obtuse angle W shown at the bottom here. So again, I start with my reference arc, and I could make this any size I want as long as it's the same, as long as it crosses through both rays. And then before I can copy that reference arc over, I do need a ray to work with here. So the bottom ray is what I started with, and that's just with a straight edge. So then I have my compass set to this reference arc. I'm going to set the middle point on the new endpoint of my new ray and mark a reference arc to match it. Okay, and then once that reference arc is marked, I need to measure the distance between the 2 intersection points on the original ray. So it's this distance here that I'm highlighting. my compass is set to that distance, I can then pick it up and move it over, put the metal point on the intersection of my new ray, and mark how far along the arc it is. Once I have that point, I can then make a second ray, and my angle has been copied. And I could check it with a protractor, but it's going to be very close. It may have a little margin of error for being a pencil and paper construction, but it's going to be certainly close enough. All right, on to the next page. If we're trying to create parallel lines, this is going to be done on the concept of corresponding angles. So we know that if corresponding angles are equal, then lines are parallel. Well, it works both directions. If lines are parallel, corresponding angles are equal, but also we're actually going to be employing the converse here, that if corresponding angles are equal, the lines have to be parallel. So to construct a line parallel to M, so I have line M first, right? And I need to go through point A. Typically that's how it works. You're supplied with a point off the line and a line to go parallel to it. So if I have that, the first thing I want to do is pick any point on line M and connect it to A. So this here is going to act as my transversal. And that was just arbitrarily drawn. It could have been at any angle as long as it hits line M. I chose to go at this angle. Doesn't matter. But then once you've established that angle, what you need to do is essentially reproduce that angle. So I'm going to call this angle B. So then if I take my compass point and line it up on point B, I can make a reference arc. And that reference arc here could have been any size, but I have it at this size. I slide my compass up to point A, and I make exactly the same arc. All right. So basically, the transversal is counting as a baseline for both angles. That's essentially what's happening here. Then to figure out how far along that arc to make my intersection, I just need to come back to angle B and measure the distance of the arc with my compass. And this is the thing that people get messed up on. When you measure the size of that reference arc, pick up your metal point and put it up here. Do not put it back on point A because you've already marked a point from point A. You need to mark your second arc from where the first arc hit the ray. And so now that's going to be in this area. And then what you see is another point that's off of the transversal that you can then connect through point A. If it doesn't make a parallel line, then something clearly went wrong, so you will know right away whether you did it right. But I would say that the most common mistake that I see with this is people make that reference arc from A, but then they also make their secondary measurement arc from A. You want to make sure you come up to the arc mark. All right, and so the reason why it works, as I mentioned before, is that if corresponding angles are congruent, lines are parallel, and I have just constructed angle A to be the same as angle B. Since they share a transversal, the lines that they cross must be parallel. All right, so given the lines below and the points not on the line, construct lines parallel. So we'll go through one of these once again, and then I'll leave you to do the second one. So I started with line N and point R. So I made first I made a transversal. You always need to start there. Connect your external point to the line that you're trying to go parallel to. We need a transversal first. That creates an angle, and that angle needs to be marked with a reference arc. So then you take your metal point from where I'm pointing to and slide right up the line to point R and recopy that reference arc. Same arc. Then we come back to the original angle and we measure how big the arc is. So I set my compass point here and my pencil point here just to mark that distance. Slide that up the line. Remember, to the arc marking, not to R. Measure that distance. And I have my new angle copied. All right, so the assignment now is to try part B and see if you can get it to look the same way using that same procedure.